Okay, everybody, I'm going to go over number 5 for you. Okay, and number 5 is talking about we have a gas that's collected over or by water displacement. Remember, your brain should say, you said water displacement, Miss E. That means that I am using my table up here to figure out something. I don't know what it is yet, but we will figure it out. Okay, so now it says that its partial pressure, so this is the gas that we're collecting, its partial pressure is 50.00 kilopascal. And then it says that the total pressure of gas over water is 78.02 kilopascal. Okay, what that means is that our gas that we collected has a partial pressure of 50 kilopascal. Now, if you wanted to figure out the partial pressure of water, I'm going to need to get rid of the water. So I'm going to need to subtract the gas from the total to give me the partial pressure of water. Okay, so let me map it out for you. If you remember before, right, we talked about this. So we have, a little small, make sure I make that a little bit bigger for you. Okay, so we have the total pressure of that system, okay, or the barometric pressure is going to equal, we're collecting over water, the partial pressure of the gas plus the partial pressure of the water that came along for the ride. All right, so now it's asking me for the partial pressure of water. So essentially, I'm looking for this. Okay, and then I have two values. So I have 50 kilopascal and I have 75 kilopascal. So here we go. This is what it is. So our P total, it is telling me what the total pressure is in the problem. It says it is 75.02 kilopascal. Okay, and then it is telling me that the gas that we collected has a partial pressure of 50 kilopascal. So that means P gas is going to be 50 kilopascal. Now it's asking you, what is the partial pressure of water? Okay, so if you were to rearrange this whole equation, you could do that. I'm just going to plug in the numbers and then we'll solve it from there. So P total is going to be 75.02 kilopascal. And that's going to equal my P of the gas, which the problem says is 50 kilopascal. And then it is asking me for the partial pressure of water, which I don't know. That's what I'm trying to figure out. So if we were to rearrange this equation algebraically, you would have to take 75.02 kilopascal and subtract 50 kilopascal, and that will give you the answer. So as long as you can subtract, the number that you're going to get is 25.05 kilopascal. Okay, so that is the partial pressure of our water right here. Now, I would love to leave this answer this way, but the second part of the question means I'm going to have to do something to this number. So the second part of the question says, what is the temperature at which the gas was collected? Okay, so that means I'm going to have to use the table. Unfortunately for me, my table is in millimeters of mercury, not kilopascal. So we're going to need to convert our 25.02 kilopascal. Remember, if it makes you feel better, put it over 1. And you're going to need to have your kilopascal in the denominator because it's in the numerator on one side. And we're looking to go to millimeters of mercury up top. If you remember your conversion factor, it is 101.325 kilopascal in 760 millimeters of mercury. So take 25.02, multiply by 760, divide by 101.325, and you will end up with 187.7 millimeters of mercury. Now, I'm sure you guys are saying, yo, Missy, I don't know what to do with that number. Guess what? We need to bring it back up to our table. So the number that we're looking for is 187.7. So what we're looking for is we are going to take a look on, obviously, the millimeter of mercury side, right? Because that's the important column right now. And wherever we find it, we will look for the temperature in degrees Celsius, and that will be our answer. So let's take a closer look. The number I'm looking for is 187. Okay, so it looks like right here, we're at 149. And then it looks like at 70, we are at 233.77. So here's the deal. The chart isn't giving me an exact number, right? It is somewhere in between these two. So in your answer, it should be somewhere in between those two. So what I would say is it is approximately 60 degrees Celsius to 70 degrees Celsius. And that would be my answer, okay? Because there is no answer for 65 degrees Celsius. Maybe that's the one I need, but the best answer is to say that it is in between those two. Okay, hopefully that was helpful.